Yo, 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 yo. Hello, everybody. We're going to talk about equations again with rational numbers. So part one was all about fractions. This one is all about decimals. So what we're going to do is we're going to do something very similar to what we did with fractions. Our goal is going to be, just like with fractions, our goal is to get rid of the fractions by multiplying by a common denominator. Well, our goal here is going to be to get rid of the decimal. And really, it's under the same idea. What we're going to do is we're going to multiply everything by either 10, 100, or 1,000. Depending on how many decimal places we have to move it. The reason why we multiply by 10, 100, and 1,000 is whenever I multiply anything by 10, like if I were to multiply 0.1 by 10, it just moves the decimal over once, and that just becomes 1. If I multiply this by 100, it would move the decimal over twice, and then I would have to add a 0. So whenever we multiply by 10, 100, or 1,000, it helps us just move decimal places. So that's what we're going to do. So the same idea as fraction, we're going to multiply every single term by the same thing, but we're not even really going to multiply it, we're just going to move the decimal. So here's what I mean by that. If I look at this one, I have two decimals here. There's no decimal here, and that's fine. That's not a decimal, that's supposed to be like a period at the end, so ignore this. So let me even do one of these. Alright, it's gone. Now, so I have two numbers after the decimal. So if I wanted to get rid of this decimal, what I would need to do is I can move this decimal over twice, and then it's gone. Then it just becomes 95x. That's the same thing as multiplying by 100, but if we wanted to multiply this by 100, I have to multiply every single term, which means I have to move the decimal over twice over here as well. And then I also have to move my decimal over twice over here, which means I have to add 2 zeros. So to get rid of the decimal, we can just move every single decimal over, but we have to move it the same amount for each and every single value. So no matter what, we have to move it the same amount of times for each and every single one. So I chose to move it twice because that got rid of it, so I got to move it twice for every single number. Now I don't have a decimal. Now I can solve my equation the same way we always do. Remember, we're allowed to use calculators, so even if you have sometimes when we move the decimal over, we create big numbers like 6,000, but it shouldn't change anything, especially when we have the ability to use a calculator. So for this one, I'm going to subtract 55x from both sides because that makes that go away, and then that leaves me with 40x equals 6,000. Now I get to divide by 40. And and again, this is where use a calculator. Let that do the work for you. 4 goes into 60. I know that goes into 60 15 times. And then I'll add the 0. So x equals 150. So recap, if you have decimals, just move the decimal over the same amount of times for each one, and that'll get rid of your decimal. Let's do, let's look at this one. Okay, so this one over here, again, I want to see how many times I have to move my decimal. What's the most amount of times I have to move a decimal to get rid of it? Well, it looks like twice, because if I move this over twice, it's going to be 125x. Alright, well, let's do the same thing for all of these. That's going to be 75x. I don't need to write the 0 in front anymore. There's no reason to. And then I got to move it over twice to make it 5,000. Alright. Now this is of course optional. Since we have a calculator, you could just subtract 0.75 from both sides. That'll give you 0.5, and you could divide. That works as well. This is just one of those things where if decimals give you anxiety, if you don't like decimals, you can always do your operations with the decimals. That doesn't matter. And that's totally fine. You're going to get the same answer. So this one I get 50x equals 5,000 because what I did is I subtracted 75x from both sides. And I just got to divide by 50. Alright, let's see here. 5 goes into 500 100 times. So there we go. So x equals 100. So again, if you wanted just to not have to do this extra step, if you didn't want to rewrite it, just use your calculator and do the work with the decimals, and that's totally acceptable. Okay, try this last one on your own, please. So pause it, try it, see how you do. So hopefully you have an answer already and you've already moved your decimal. But that's what I'm going to do right now. I'm going to move it over once. Once. I don't have to move it over once. Not twice, because there's only one number after the decimal to get rid of. And then I'm going to rewrite everything in my equation, just so that it looks nice and clean. There's no confusion. And there we have it. Now I'm going to start solving my equation like normal. I'm going to subtract 21t from both sides just to get my variable to the same side. Let's see, this is going to give me 52t negative 222. So I got to subtract 220 from both sides. Weep, I'm running out of room, so I'm just going to go off to the side here. I still have 52t on my left. I'm really just adding these up. That's 442 because I have a negative and I'm subtracting more. And then I gotta divide both sides by 52. Now, I don't know the answer to that division. I don't feel like dividing. I'm gonna use a calculator real quick. I'm just doing one in my hand. 442 divided by 52, 8.5. And I'm done. So I'm still showing all my steps. And I just moved my decimal over once just to get rid of it. Okay. Now, you also might have to write down some word problems first and then solve with these types of problems. So Javier walks from his house to the zoo at a constant rate. After walking 0.75 miles, that's 3/4 of a mile, he meets his brother, Raul, and they continue walking at the same constant rate. So that constant rate matters, right? So that's the speed. When they arrive at the zoo, Javier has walked for half an hour and Raul has walked for 0.2 hours. What is the rate in miles per hour at which the brothers walked to the zoo? So here's what we know. We know that, let's see here, Javier, he walked 0.7 miles in the beginning. And then he also walked an additional 0.2 miles, okay, because this is the amount that Raul walked right here. So, and then that 0.2 miles was at the same rate. So that 0.2 hours was times the rate that he was walking is going to, plus that 0.7 miles is going to give me the total distance that he walks to the zoo. We also know that he walked on the 0.5 hours as well. So this is, I know that he walked 0.2 hours plus the 0.7 miles, and I know that he walked 0.5 hours plus, and then whatever rate he was walking, which is that constant rate. Kind of a confusing problem to set up. Okay, but his distance is, we know that it was 0.2 hours plus that 0.7 miles, and we know that it was a half an hour. But here's the equation, and this is what I want you guys to solve. So let's focus on solving this. So pause it if you haven't paused it yet. Pause it and then try this one on your own. And if you want to, you don't have to get rid of the decimal. That's okay. If you wanted just to solve it with keeping the decimal and using a calculator, it does not matter to me. Solve it if you haven't done so. Pause, solve. Okay, I'm going to solve this one without getting rid of the decimal. So I'm going to subtract 0.2r from both sides. And the reason why I'm doing this is because I have the ability to use a calculator. It makes it a little bit less intimidating. Because then I just got to divide by 0.3. I'm just dividing by the number that is provided to me. That's gone. So then I'm going to be given the rate once I do my division. So I'm going to do 0.75 divided by 0.3, and I'm going to get 2.5. So the rate was 2.5 miles per hour. Okay, so let's look at the second equation here and see how we do on this one. So Logan has 2 aquariums. One aquarium contains 1.3 cubic feet of water, and the other contains 1.9 cubic feet of water. So here's a larger one, here's a smaller one. The larger aquarium weighs 37.44 pounds more than the water in the smaller aquarium. So that's how much more they weigh. And then this one. Write an equation with a variable on both sides to represent the situation. Then find the weight of 1 cubic foot of water. So, well, let's see what we know. We know the larger, let's go with the larger one. So the larger aquarium is 1.9 cubic feet of water. Well, we don't know how much a cubic foot of water weighs. I'm going to use X for that. Because if I know that the total weight would be however much a pound of water weighs, okay, I'm sorry, how much, not a pound, but how much a cubic foot of water weighs, that's my unknown value. So whatever the weight is of 1 cubic foot of water times the amount we have 1.9 of those, that's going to give me the total weight of the large container. Well, the small container, what I know is I know that it is 1.3 cubic feet of water, so that's 1.3 cubic feet times however much that weighs per 1 cubic foot. But we also know that if I add 37.44 pounds to this, it's going to be the difference between these two aquariums. Because the small one weighs this much, plus an additional this much would give me the equivalent of this one. So there's my equation. So then from here, we should be able to solve. So last one that we're doing today, so try to solve it, pause it, see how you do, and then when you unpause it, I'll have the solution actually ready for you on this one. So pause it and try it out. Just give it a shot and see how it goes. Okay, so here's the solution over here. So first what I did is I subtracted the 1.3x from both sides. I got 0.6 divided by 0.6 on both sides. I get 62.4. So that was one way to do it. Another way to do it was I could have moved my decimal over once if I wanted to. That doesn't get rid of the decimal though. That just gives me 19x equals 13x plus 374.4. So I still have a decimal here, but maybe we feel better about not having a decimal with our variable. And then, or I could have moved it over again, and that's going to add some zeros to make this 130, 190, 3,744. Doesn't change anything. Your answer is still going to be 62.4. So if you want to, you could have gotten rid of the decimals to get rid of that decimal anxiety, or you could have just done the math with the decimals in a calculator. Okay, that's all I got for you. So if you choose to get rid of the decimals, move decimal in every term. Just like with the fractions, we got to multiply everything. We have to move our decimal for every term. Okay, that's it. Try this one on your own, see how you do. If you guys have any questions, please don't hesitate to ask. Let me know. Greedius out.